Good morning, ladies and gentlemen. Our guests will be arriving soon. May I remind you to switch off your cell phones. For those who wish to use the earphones, Channel 2 is for Chinese and Channel 3 is for English. Honorable guests, honorable members of Shantou University, ladies and gentlemen, welcome to Shantou Dialogues. I'm Stephanie Liu, a second-year law student at Shantou University, and I'm the MC for this morning. First, let me introduce Ms. Anna Wu, who is the chair of the organizing committee of the Shantou Dialogues. Ms. Wu was a former legislator in Hong Kong and a lawyer. She previously chaired the Consumer Council of Hong Kong and in that capacity promoted sustainable consumption for many years. Ladies and gentlemen, please welcome Ms. Wu.
Ladies and gentlemen, thank you very much for coming, and thank you, Stephanie, for the introduction. I'd like to welcome you to Shantou University and Shantou City. On behalf of the Li Ka-shing Foundation and Shantou University, I'd like to extend our warmest welcome and our appreciation for your being here. We're honored and we're privileged to have all of you here joining us on this very significant series of discussions. We started several years back on the theme of sustainability, and this theme has taken different forms, and this year we're talking about the green economy. One of the very special and endearing features about Shantou Dialogues is the very intimate setting that has been provided for members and participants to interact with each other quite freely, to discuss topics candidly, and above all, to challenge our minds to think outside the box. The university is a green campus. We take a holistic approach towards the development of the culture of a green economy, where we must begin with the minds making a paradigm shift towards not to waste, look for alternatives, find the best fit, and find the most effective strategy for ourselves. This is really work in progress on the campus. As you know, Shantou University is a huge experiment for the Li Ka-shing Foundation. Its mission is to engineer education reform in the university sector, as well as, and hopefully, to produce critical, caring, and creative minds. Ladies and gentlemen, I hope during your stay here, albeit short, that you will be able to enjoy our green campus, interact with our students. They love you and they like to talk to you, and help us to think outside the box. I now have the pleasure to introduce Professor Lovins, who's right there. Professor Lovins needs no introduction from me at all. He has advised the energy sector, governments, heads of state on natural capitalism and oil and energy. His work in 50+ countries really has put him on the map and has earned him many awards and honorary degrees. He co-founded and leads the Rocky Mountain Institute, which is a think and do tank. Professor Lovins has written many books. His Pentagon-sponsored 29th book, Winning the Oil Endgame, will be published in Chinese in early 2009. Professor Lovins is going to talk to us about Beyond Oil, taking our minds into new frontiers. So please, let's welcome Professor Lovins. Professor?
Sure. Thank you for the honor of outlining briefly some profitable solutions to three of the world's big problems: oil dependence, climate change, and the spread of nuclear weapons. Those who want more technical detail, please see me afterwards, and I have some papers for you. We are often offered a stupid multiple choice test. Do you prefer to die of climate change, or oil wars, or nuclear holocaust? Of course, a better answer, which we are seldom offered, is none of the above, because all of these problems go away if we use energy in a way that saves money. Some of you may remember that the Hubble Space Telescope in outer space had the mirror ground in the wrong shape because someone had mixed up a plus sign and a minus sign in an equation. The climate protection debate is like this too. Economic theorists tell us that protecting the climate will cost a lot, so the politicians argue about cost and burden and sacrifice. But somehow the theorists forgot that it's cheaper to save fuel than to buy fuel. Efficiency is cheaper than fuel. Therefore, the solutions to climate change are not costly at all. They're profitable. Once more of our leaders understand that this sign error has occurred and that they should be talking about profits, jobs, and competitive advantage, any remaining resistance to protecting the climate will melt faster than the glaciers. Many companies understand this, and whether they worry about climate or not, they are saving energy as fast as they can to make money. Two of our biggest chip makers have been cutting their CO2 emissions 6% every year by making their plants more efficient, and they get their money back in 2 or 3 years. DuPont has already cut its greenhouse gas emissions 80% below the 1990 level and made $3 billion by doing so. Dow has made even more profit substituting efficiency for fuel. BP made over $2 billion profit, meeting its carbon reduction goals 8 years early. United Technologies has cut its energy per dollar by a remarkable 45% in just 5 years. General Electric is raising its energy efficiency 30% to build shareholder value. Interface has cut its total greenhouse gas emissions by 82% while growing the business and making profit. Texas Instruments recently built a chip-making plant in Texas, not China, because together we were able to take out 30% of the capital cost along with much of the energy and water use. So while politicians debate theoretical costs, smart companies are racing to get the real profits before their competitors do. The consulting firm McKinsey published a supply curve showing how many euros you save or pay to reduce the world's greenhouse gas emissions in 2030 by 1 ton of CO2 equivalent. And it turns out that the profitable savings from energy efficiency very nearly pay for all of the more costly measures. So the average cost of saving 46% of the emissions is only about 2 euros per ton. Soon they will publish new results showing much bigger savings at a similar cost. Now, how fast would we have to save energy to protect the climate? Economic theorists normally assume that the energy used to make a unit of GDP will keep going down by just 1% per year, as it has in the past. In that case, CO2 emissions triple by 2100, and we are all toast. We're barbecue. If, however, we could cut energy intensity by 2% a year, then the carbon emissions would level off. And if we could cut intensity 3 or 4% a year, the emissions would go down enough to stabilize the climate if irreversible changes have not already started. Is this possible? Well, the United States routinely cuts its energy intensity 3 or 4% every year without even paying attention. California is 1 percentage point faster than that. China cut its energy intensity 5 to 8% a year for over 25 years through 2001. I've named some of the attentive companies that cut their energy intensity 6 to 15% a year. So why should 3 or 4 be hard, especially because most of the energy growth is in countries like China and India that are building so much infrastructure the first time, and it's much easier to build it right the first time than to fix it later. And since everybody who buys energy efficiency makes money, why should this be costly? In the United States, we know in great detail how to save half our oil and gas and 3/4 of our electricity at a cost 8 times lower than the price of that energy today. Japan uses 2 or 3 times less energy per dollar of GDP than the United States, and yet the Japanese government has found ways to profitably triple Japan's energy efficiency. Now, Japan uses 7 to 9 times less energy per dollar than China does. So if you combine these two numbers, we see that over the long run, it should be possible for China to have an economy 20 times bigger than today and still use slightly less energy than today. I want to tell you briefly 2 stories about how to do this, one about oil and one about electricity. Each of them accounts for about 2/5 of the fossil fuel carbon emissions. Let's start with oil. 4 years ago, Rocky Mountain Institute published a study called Winning the Oil Endgame, the one that will be published soon by Tsinghua. It's very detailed and co-sponsored by the Pentagon, which does not want to fight over oil. It's written for business and military leaders around business cases, and you can get it all free at oilendgame.com. It shows in detail how by the 2040s the United States can completely eliminate its use of oil and have a much stronger economy, and how this transition can be led by business for profit. With similar technologies, but the special Chinese way of doing things, I suspect that China can do much the same thing, probably faster. Now, the U.S. transition beyond oil can look like this. The use of oil and the imports of oil are officially projected to keep going up. But we could turn them down along these green curves by redoubling the efficiency of using oil. We've already doubled it since 1975. We can double it again at an average cost of $12 per saved barrel. And then we could go down more steeply along the blue curves by replacing the other half of the oil with a mixture of saved natural gas and advanced biofuel made from woody, weedy things like prairie grasses, logging wastes, crop wastes, but without hurting the soil and without interfering in any way with the food system. And we know that this sort of thing works because the last time we paid attention to oil, from 1977 to 85, our economy grew 27%, but our oil use went down 17%. Oil imports fell by half. Imports from the Persian Gulf fell 87% and would have been gone in the next year if we'd continued. And OPEC's exports fell by half, breaking their pricing power for a decade because we customers could save oil faster than OPEC could conveniently sell less oil. So we had more market power than they did. Well, now we could do the same thing all over again, but the rewards for investing in going along these lower curves are so very profitable that this transition can actually be led by business. There are some important policy innovations from the public sector that can help this happen better and faster by supporting and not distorting the business logic. But this transition, we found, would not require new energy taxes, subsidies, mandates, national laws, or anything else that either political party in my country wouldn't like or could mess up. Now, the key, of course, is transportation, because vehicles use 70% of U.S. oil. But if we make vehicles lighter and more slippery in moving through the air and along the road, and give them advanced propulsion, then we can triple their efficiency very cheaply. It's like buying gasoline at 15 US cents per liter. And you even get better performance like this car, which does 250 kilometers an hour and 40 kilometers per liter, although not at the same instant. And the surprise to many is that the ultralighting that doubles the efficiency of these carbon fiber concept cars does not increase their production cost. You'll see why later. But then if we apply the same logic, we can get airplanes that already save 20% of the fuel for no extra cost and can save close to 2/3 at very low cost, 2 or 3 year payback, and heavy trucks that already save 1/4 at no extra cost and can save 2/3 with about a half-year payback. So when we put this all together, even without worrying about how to save most of the oil used in buildings and industry, the other 30%, we see there's a huge potential for wringing more work out of each barrel of oil, and the technology to do this keeps improving very quickly. To understand how this works in a car, which every day uses 100 times its weight in ancient plants, we just need to look at the physics of a car. 7/8 of the fuel energy never reaches the wheels because it's lost in the engine, idling, driveline, and accessories. Of the 1/8 of the energy that does reach the wheels, half of it heats the tires and road or heats the air that the car pushes aside, and only the last 6% actually accelerates the car and then heats the brakes when you stop. However, only 1/20th of the mass you are accelerating is you. The rest is the heavy steel car. So only 1/20th of 6%, or 0.3% of the fuel energy moves the driver. Not very good. But 3/4 of the energy needed to move the car is caused by its weight. And every unit of energy we save at the wheels saves 7 more units of energy that we need not waste getting it to the wheels. So there is huge leverage in making the car radically lighter weight, whether through light metals like aluminum or ultralight steels or polymer composites. And it is the carbon fiber composites that we used 8 years ago with the industry to design this mid-size SUV that can carry 5 adults in comfort, 2 cubic meters of cargo. It can haul a half ton up a 44% hill. It accelerates 0 to 100 kilometers an hour in about 7 seconds. And it gets 28 kilometers per liter. And would have an extra price of just $2,500, not because it's ultralight, but because it's hybrid electric. And the reason it doesn't cost more to make it ultralight becomes clear when you look at the body of this car, suspended from rings like an airframe. There are only 14 parts in the body. Each can be lifted with one hand and no hoist. In fact, this big part I can briefly lift with one finger. and and would have an extra price of just $2,500, not because it's ultralight, but because it's hybrid electric. And the reason it doesn't cost more to make it ultralight becomes clear when you look at the body of this car, suspended from rings like an airframe. There are only 14 parts in the body. Each can be lifted with one hand and no hoist. In fact, this big part I can briefly lift with one finger. And then the parts are each made with one low-pressure die set. A steel car has 10 or 20 times more parts, each with 4 steel stamping die sets. So we just saved 99% of the tooling cost. And a set of tooling for a car costs $1 billion. And then these parts snap precisely together for bonding, so you don't need the jigs and robots and welders. No body shop. You put color in the mold, no paint shop. These are the 2 hardest and costliest parts of making the car. So you need at least 2/5 less investment than for the leanest plant in the industry. And now techniques for making cars this way have been developed, one by a little company I chaired until last year. So here's a test piece made of carbon fiber composites. Maybe we make temple bells out of it. This is tougher than titanium. You can beat it with a huge sledgehammer and it just bounces off with no damage. This absorbs 12 times as much crash energy as steel per kilogram. But if you make cars out of it, half the weight and half the fuel use go away, and the car costs the same to make because of the simpler manufacturing and because the propulsion system is 3 times smaller. So we can pass this around. Don't worry, it won't break. I'm sorry, not to throw wetter. But I think you'll find it interesting. And Toyota recently showed, a year ago, a concept car made of carbon fiber. It has the same interior volume as a very popular hybrid called the Toyota Prius, but it weighs 1/3 as much, 420 kilograms, including 20 kilos of extra batteries to make it a plug-in hybrid. And it uses only half as much fuel as that very efficient hybrid. This might be considered just bragging because most concept cars are never mass-produced, except that the previous day, the world's biggest maker of carbon fiber, Toray, had announced a big factory to mass-produce carbon fiber car parts for Toyota. And a few months ago, Honda and Nissan announced a similar deal. Clearly, this is a statement of strategic intent. It is not done for amusement. So here's where cars can go. You start using a certain amount of oil, and if you make it hybrid electric, you save half the energy. If you make it ultralight and slippery, you save half again. If you run it on cellulosic ethanol, you save another 3/4 of the oil. If you make it a plug-in hybrid, you save at least half again. Now you're using 3% of the oil you started with. And many people would actually make money buying such cars because when the car is parked, it will be able to talk intelligently to the grid through the building and sell power back to the grid when and where it's most valuable. The car fleet will have many times more generating capacity than the power companies have. So we don't even need to get to the hydrogen possibility or battery cars to get within a few percent of eliminating oil, and then those options too will make money when the car is so efficient. Now, you might think about this as a matter of competitive strategy. In 1997, Boeing was in as much trouble as the American automakers were 10 years later, and Airbus was pulling ahead. But then Boeing announced a new airplane, the Dreamliner, now being made substantially in China, by the way, that is made half of carbon fiber. It's very light and slippery. It saves a fifth of the fuel at no extra cost. And now it has almost 1,000 orders. It's sold out into 2018. It's the fastest order takeoff of any plane in history. And in just a few years, Boeing pulled ahead of Airbus by turning this efficiency leapfrog into a breakthrough competitive strategy and putting those innovations into every airplane that Boeing makes. Well, this is a very interesting approach, and no government told them to do this. They just thought it made good business sense. So in my institute, we do institutional acupuncture. We figure out where the business logic is congested and not flowing properly. And to get this qi flowing properly in the meridian, we put needles in it. And Boeing, of course, has already done this itself for airplanes. We persuaded Walmart to buy double efficiency trucks, which its suppliers will very soon be making, and then everybody can buy those trucks because we use Walmart's demand pull to drag the trucks into the market. The Pentagon is now the government leader in getting America off oil, so they don't need to fight over the oil, and so they don't lose so many lives and so much treasure trying to deliver the oil to inefficient platforms. But when the contractors that make our military platforms start competing and valuing oil under the new rules 10 or 100 times higher than before, that will give us many new technologies for the civilian vehicles, much as military research in the past gave us the internet, the global positioning system, the jet engine industry, and the microchip industry. There's huge advance in biofuels and in financing clean energy. It got $148 billion of private capital last year in the world. And we knew that cars and light trucks would be slower, but in our book we suggested that Detroit should try Boeing's strategy. And 2 years later, Ford hired the head of Boeing Commercial Airplanes to run Ford. Now, as this tsunami of creative destruction washes over the American car industry, it's changing the managers or their minds, whichever comes first. There's huge competitive pressure, especially from China, thank you, for changing fundamentally how we make cars. And please feel free to pass that bowl around if you would like to see it. Now, the same thinking applies to industry. For example, pumps and fans use half of the motor energy, and motors use most of the world's electricity. In a typical pumping loop in a factory, we were able, with some ideas from a Chinese engineer, to cut the energy use by 92%, and yet it cost less to build and it worked better, simply by using fat, short, straight pipes rather than thin, long, crooked pipes. This is not rocket science. This is good Victorian engineering rediscovered. Oh, and then we found we'd left a factor 4 on the table. We should have saved 98% at even lower cost. Sorry, we'll do better next time. But this example is actually quite typical of what we find throughout industry, especially if we start saving downstream. For example, if I put 100 units of coal into a power plant and lose most of the energy at the plant and more in the grid and more in the motor and the pumps and the pipes, only 1/10 of my original energy comes out the pipe as flow. But if I now save flow or friction in the pipe, then these compounding losses turn into compounding savings, and I save 10 times that much fuel, cost, and pollution at the power plant. Also, my equipment as I go upstream gets smaller, simpler, and cheaper, so I save more capital cost. And it's often rather simple. Often we see a pump, next to it another pump. They're supposed to send something up a pipe, but they're drawn like this and then they're built like this. So all the time the flow goes through two 90-degree bends. That means friction, and usually two valves, more friction. Why don't we do it this way, with no bends and no valves or one valve? Well, we just don't normally do it that way. But when my colleague Peter Rumsey made this change in a piping system, as a retrofit, he saved 75% of the pumping energy and eliminated 15 pumps that will never again waste energy and maintenance. Now, saving electricity really works. The average person in California has used a constant amount of electricity for the last 30 years, while her real income went up 79%. And this meant California saved $100 billion worth of power supply investment compared with the national average, thus making the state more prosperous. Half of this saving came from state standards for buildings and appliances efficiency. The other half came from a simple reform that rewards the utilities for cutting your bill, not for selling you more energy. How much more could we do? Well, based on the measured cost and performance of about 1,000 technologies to save electricity, we worked out in 1989 that altogether about 3/4 of U.S. electricity could be saved at an average cost that today would be about 1 cent per kilowatt hour. That's cheaper than running a coal or nuclear plant, even if building it were free. Similar findings came from Europe. The American Utilities think tank found a somewhat smaller and costlier, but still very big and very cheap potential. And it keeps getting bigger faster than we use it up. You know the expression low-hanging fruit. Well, the fruit has fallen down on the ground. It's mushing up around our ankles. It's spilling in over the tops of our boots, and the innovation tree keeps dumping more fruit on our head. Especially when we think about new methods of design to put together technologies in new ways. So this is my house. It does not have to look like this to work like this. It is 2,200 meters up in the Rocky Mountains near Aspen, where it can go to minus 44 Celsius. You can get frost any day of the year. You can get 39 days of continuous cloud in midwinter. And yet, if you come into this atrium out of the snowstorm, you're in the banana jungle where I've harvested 28 banana crops with no furnace, because it was cheaper up front not to put in the heating system, but instead to put in very thick insulation and windows that insulate like 14 or even 19 sheets of glass, but look like 2 and cost less than 3, and ventilation heat recovery. I ended up saving 99% of the energy for space heating and water heating, half the water, 90% of the household electricity, and the extra cost was $16 per square meter and paid for itself in 10 months 25 years ago. Now we can do much better. Here's a house that's comfortable at 46 degrees with no air conditioning and costs less than normal to build, about a 90% saving compared with the US norm. Here's a house in Bangkok, exactly normal construction cost, better comfort, 90% saving on air conditioning energy. Here's a building at Stanford University where it also gets very hot. It's actually a wet laboratory, which is a very difficult kind of building for energy use. But it has no air conditioner, very satisfied occupants, and exactly normal construction cost. They get over 50 units of cooling per unit of electricity, and with better pumping and pipe design, it would be over 100. So this saves 80 and should have saved with better pumping 90% of the energy allowed by the strictest US standard. So the key to all of these buildings spanning the range of the Earth's and China's climates, I mean, basically I live in Tibet and the Bangkok house is like Guangdong. These are all telling the same story, that if you optimize the house as a system rather than the components by themselves, you can make very big savings cost less than small or no savings. In other words, you get expanding returns, not diminishing returns to investments in efficiency. And then, because the building uses so little energy, it's very easy and still has very good economics to produce all the energy in the building itself, whether in my house or this office building going up in Paris, this building in a hot and cold, cloudy place called Ohio, or the new Ningbo building with Nottingham University. This one should produce all the energy it uses from renewables. Now, the same we find in industrial practice. We've lately redesigned over $30 billion worth of plants in 29 sectors of the economy, everything from petrochemicals to microchips to data centers to mines. In retrofits, we find 30 to 60% savings, 2 or 3 year paybacks. In new construction, we find 40 to 90% savings, and the capital cost goes down, not up. Of course, none of this would be possible if the original designs had been optimal. So we aim at a revolution in how engineering is taught so that things will be designed right the first time. I gave lectures on this at Stanford Engineering School, and those are now being translated into Chinese. So early next year, they should be available here. Now, of course, some people think that nuclear energy could be an answer to climate because it doesn't emit carbon, at least directly. However, there is no nuclear revival in market economies. In the United States, we have subsidies over 100%, but still zero private investment. And it actually turns out that this is a good thing for climate protection, because nuclear is now so expensive that it gives you 2 to 11 times less carbon reduction per yuan invested than if you bought efficiency or micropower instead. I'll explain micropower in a moment. In other words, since climate is a problem, we need to get the most solution per yuan and the most solution per year. And there are other low or no carbon investments that are much cheaper and faster than nuclear, so we should buy those instead. And that is what the world is doing. This graph shows how much electricity is made in the world by micropower. The larger part of this micropower is combined heat and power, or cogeneration, making electricity and useful heat together in buildings and factories. This saves at least half of the fuel cost and carbon. The other parts here are renewables other than big hydro dams. And you see they're small but growing very, very fast. So much that they now provide 1/6 of the world's total electricity, slightly more than nuclear, 1/3 of the world's new electricity, and from 1/6 to over half of all electricity in 13 industrial countries. In fact, in 2006, worldwide, nuclear added less capacity than photovoltaics added, 1/10 what wind power added, 30 or 40 times less than micropower added. In 2007, China or Spain or America each added more wind power than the world added nuclear power. And the US added more wind power than it has added coal power in the last 5 years combined. It's a very simple story. Micropower and efficiency cost less and have less financial risk than any kind of central plant, nuclear, coal, gas-fired. And therefore, the smaller plants and the savings are getting the investment and now provide most of the world's new electrical services. There are 2 key policy innovations you might consider to make this happen faster. to get efficient cars on the road, offer a combination of a fee and a rebate. That is, a fee on less efficient cars and a rebate for more efficient cars within each size class. So this pays for itself, and it is more profitable for automakers. It's more effective than either fuel taxes or standards, because standards are obsolete before the ink is dry, and there's no incentive to do better than the standard. But fee-bates drive continuous improvement. They were tried just this year in France and immediately were so successful that the government wants to extend them, extend them to 20 other products, and they could be applied also to new buildings. When you connect your new building to the grid, you would pay a fee or receive a rebate depending on how efficient it is. And this will tell you to design it better. And then for electricity and gas companies, the most important thing we can do is to decouple the utility's profits from how much energy it sells. So it's not rewarded for selling more or penalized for selling less. And then let the company keep as extra profit a small part, maybe a tenth of what it saves for the customers. This alignment of interests is very profitable for all parties, and it really makes the utility enthusiastic about efficiency. That's what was behind the success in California, for example. But now it's spreading rapidly across the United States with support from the utility industry, because they save so much money and risk this way. There are 5 myths I want to conclude with about implementation, and then just 2 quick comments on China. We're told none of this is happening. Why not? Well, how many of you knew that 2 years ago, and there's no incentive to do better than the standard, but fee-bates drive continuous improvement. They were tried just this year in France and immediately were so successful that the government wants to extend them, extend them to 20 other products, and they could be applied also to new buildings. When you connect your new building to the grid, you would pay a fee or receive a rebate depending on how efficient it is. And this will tell you to design it better. And then for electricity and gas companies, the most important thing we can do is to decouple the utility's profits from how much energy it sells. So it's not rewarded for selling more or penalized for selling less. And then let the company keep as extra profit a small part, maybe a tenth of what it saves for the customers. This alignment of interests is very profitable for all parties, and it really makes the utility enthusiastic about efficiency. That's what was behind the success in California, for example. But now it's spreading rapidly across the United States with support from the utility industry, because they save so much money and risk this way. There are 5 myths I want to conclude with about implementation, and then just 2 quick comments on China. We're told none of this is happening. Why not? Well, how many of you knew that 2 years ago, America's use of oil and coal and total energy went down? Very few energy experts know this, but it did happen because energy intensity went down more than the economy grew. And if we pay attention, we can do this regularly. We're told that nothing can happen without global agreement. But in the 11th 5-year plan, China made energy efficiency the top priority for national development, not because some treaty said to do it, but because people like Wang Zhibao understand that otherwise China cannot afford to develop. We're told that nothing can happen without carbon pricing. Well, we will all have carbon pricing before long. That will be good. We should do it. But it's not essential. It's not sufficient, because if you get the prices right but don't bust the barriers to responding to price, not much happens. And in the long run, the price effect will not be very important because of all that cheap efficiency. We're told that public policy just means taxes and subsidies and mandates, but there are other more powerful methods. I just named 2 of them, and they're more politically attractive. I don't even think public policy is the only key to this lock, or even necessarily the best key. Of course, Public policy matters. Government should steer, not row, and they should steer in the right direction and get the rules right. But the heavy lifting will probably be done more by business in its coevolution with civil society. And the dynamism of that system is even greater than that of even the government of China. There is so much entrepreneurship, as we see in the Chinese economic miracle, that I think we need to pay careful attention to the opportunity for breakthroughs in design, technology, competitive strategy, and those must be as much in the vanguard as public policy. Now, China, we are all told in America, has lately built a new coal power plant every week or two. We're not told that 2/3 of them were not approved by Beijing. And yet, look at the amazing success that energy savings in China from 1989 to 2001, actually 1980 to 2001, 21 years, cut the energy growth by 70%. And after a few years interruption to binge on energy-intensive basic industries, we're getting back on track to do that again. Probably China's heading again for an electricity surplus. When you look at all the new efficiency progress, the fabulous progress with micropower and other things, and the modern gas system going in, I think we'll see this again. China is already the world leader in distributed generation. By the end of 2 years ago, you had 7 times as much distributed renewables, just distributed renewables, not cogeneration, as you had nuclear, and it was growing 7 times faster. You have enough wind potential to meet all your electric needs twice over. You have 2 world-class wind resources. And in 2007, China's wind industry smashed the target for 2010. So a year ago, the Chinese industry said that compared with the 30 gigawatt wind target for 2020, they now expect to have 50 installed under current policy, 80 with better policy, and 122 with full policy support. Well, that would be 4 times the nuclear target or 5 times the Three Gorges Dam. So China, we're told, is now the biggest carbon emitter in the world. But I see a different role for China, and I think many of you do too. Think about it, the comparison with America. Your society has 5 millennia more experience than mine. You have 5 times as many brains as my country, quite possibly better ones. About 90% of the technologies underlying the Western Industrial Revolution were invented in China. Thank you very much. China is the only country to have cut energy intensity over 5% a year for over a quarter century. It's the only country with energy efficiency as its top priority for national development. It's number 1 in distributed renewable power and in many of its specific technologies, and in a few years will be number 1 in every one of those technologies. We know that China can make huge changes with a speed unmatched anywhere else. And of course, there are many huge challenges that remain, many complex problems, and heaven is high and the emperor is far away. But your paramount leaders are a lot better than ours have been for the last 8 years. You work harder, you're more highly motivated. So for all these reasons, I think we can count on China to lead the world out of the climate mess. We are the people we've been waiting for. And if anything I've said seems too good to be true, just remember that only small, weak secrets need protection. Big discoveries are protected by public incredulity. Thank you very much.
Thank you very much, Professor Lovins. That was really wonderful. May I just ask you to show our appreciation again? Thank you very much. It was really wonderful. We're going to take some questions and answers from there. What I'd like to do is, if students have questions, please go over to the standing mic over there. I would very much like to take questions from the audience, our participants for the Shantou Dialogues. And there are students who will be giving you a wireless mic. So if you've got any questions or any comments to make, please just raise your hand and we will deal with it and we'll pass the mic to you. And we will very much welcome a dialogue between our guests, students, and Professor Lovins. Thank you very much. Yes, please. Sergio, can I just ask for the mic to be handed over? Now, we do have the earphones. 3 is for English, 2 is for Chinese, and you may ask questions in English or Chinese. Please feel free to do so. Please.
Thank you very much, Amory, for a very interesting, challenging presentation, stimulating. You gave such a wide canvas. I like to take a look at a very small portion of that canvas and make a reference to E85 that you mentioned at some point. In the United States, every gas station has at least 3, if not 4, types of gasoline. I was always interested to know who buys the intermediate grades, but still they are there. And then you mentioned E85. The United States has flex fuel vehicles that were designed for E85 fuel, but they created a flex fuel vehicle and at the same time an inflexible infrastructure to deliver it, because the pumps in the US that sell E85 are very small in numbers. 140,000 gas stations and about 1,000 stations selling E85. So wouldn't it be easier to just convert one of those 3 or 4 gasoline grade pumps into ethanol pump and then let the customer help himself with whatever blend he wants to do, because his car can use up to E85?
Yeah, there's an even better way to do it, which you will find at baff.info. That's the Bioalcohol Fuel Foundation in Sweden. And that's an interesting case because, like the north of China, it's a cold place, so you need to be quite careful with not freezing the water in the hydrated alcohols. And they have a nice method of simplifying the infrastructure so that all the blending between fuel alcohols like ethanol or butanol and gasoline and other additives is done in the pump head, and the supply logistics become much simpler and cheaper. I would also recommend what Brazil does, and this would work beautifully here in the south of China where it's warm. Essentially every new car in Brazil is not just flex fuel able to go up to 85% ethanol, it's total flex. It could burn 100% ethanol. And this means there are no captive customers. So it exerts a strong price discipline on the fuel alcohol producers. And that's how Brazil has been able to become oil independent, getting over a quarter of its motor fuel from cane ethanol and the rest from offshore oil. But that's without making the vehicles more efficient. That would make it much easier.
Any other questions, dialogues, comments? Yes, Maria.
Thank you very much for a wonderful presentation. I was interested in your talk on, greenhouses and buildings, houses as systems rather than looking at different components. The general perception is that the greener house, the more expensive the cost of construction, and that one has to pay a premium to have, let's say, an efficient house. And what you showed is actually the payback is very, very, very short, and it can be very, profitable to have.
It's often
these.
negative.
Can you please comment on that?
Yeah. When I was teaching at Beda a few years ago, I found this was the point people found most puzzling, because they were used to thinking that efficient must cost more to build. The main reason this is not so is that an efficient house keeps itself comfortable without heating or cooling equipment, so you save the cost of the equipment. Think about it this way. If you look at how much energy you save versus the cost of the next unit of savings. If I add more and more insulation to my house in a cold place, the curve goes up more and more steeply. This is called diminishing returns. But then it gets to the point where I no longer need the furnace, ducts, fans, pipes, pumps, wires, controls, fuel supply arrangements. So the cost comes down to less than I started with. In my case, $1,100 less than I started with, for a 99% saving. And why should I get there the long way around when I can tunnel through the cost barrier to this destination? We've now done this from minus 44 to plus 46 Celsius. I think this handles all the climates in China, close to it. And others have done it in hot, humid climates, like Bangkok example. So I think this is actually easier even in big buildings than in small buildings. And we've done the same thing in big buildings in a similar range of climates. You know, my group has helped design over 1,000 super efficient buildings, including about a third of the world's LEED Platinum. So we see this very systematically in our practice, and others achieve the same thing. It's not magic. It's good engineering and architectural principles comprehensively and systematically applied with a lot of attention to detail. The main obstacle is that not many designers and builders know how to do this yet. But China is very good at training people in large numbers rapidly. So I think it's a great opportunity. And we even see negative cost retrofits. I give one example. We had a 19,000 square meter glass office tower near Chicago, which is both very hot and humid in the summer and very cold in the winter. It needed to have the glass on the outside replaced because the seals around the edges had failed from age. But by putting in super windows that are about perfect in letting in light without heat, very good for Guangdong climate, and deep daylighting and efficient lights and office equipment, we cut the peak cooling load by 3/4. Then we could replace the big old air conditioning system with a new one 4 times smaller, 4 times more efficient, and $200,000 cheaper than renovating the big old system. That was enough to pay all the extra costs of everything else. So we ended up able to save 3/4 of the energy at a slightly lower cost than the regular 20-year renovation you must do anyway that saves nothing.
Wow. We don't have that much time yet, but we'd like to take maybe 2 more questions. So there is a questioner over there, please. Can we have the mic passed over, please? We don't have that much time yet, but we'd like to take maybe 2 more questions. So there is a questioner over there, please. Can we have the mic passed over, please? Is the mic passed over?
It went to this gentleman
Oh,
first.
please, go ahead. You go ahead first. Yeah.
Okay, Amory, thanks so much for a very optimistic presentation this morning. I mean, so often discussions on these topics are very gloomy, so I very much appreciate your perspective. And something that certainly I'm taking away from this is your approach to the world involves sound physics, sensible economics, and a pragmatic approach to challenges, which is all very helpful. And I think that you focus, it seems to me, on what you could call elegantly simple, smart solutions, and you have a concern for changing mindsets. So I have a question, really. It seems to me that to move further and faster, we need to think about financial capital and how to switch more of that into these types of approaches to developing solutions to our challenges, and social capital, and how to build up the social capital side of the equation. As you pointed out in your last slide, the people of a country are one of its biggest resources. So my question really is, what advice would you give to national leaders around particularly this question of building up social capital to start moving the attitudes, behaviours, and ultimately the demand of consumers and citizens in a country such as China or America?
We're talking about a very complex web of changes in what we do, how we think, what we want, who decides and how. So it's hard to pick out any one piece of it. Clearly, from a technical point of view, China is on the right track, and the United States will soon join you in a very strong emphasis on energy efficiency. However, as of a few years ago, China was still spending 12 times more capital on energy supply than on energy efficiency, and it should be the other way around. Think about it this way. The power sector it takes about a quarter of global development capital. If we invest in things that save instead of producing electricity, we need about 1,000 times less capital, and we get the money back 10 times faster. So that's a 10,000 times decrease in the capital needs of the most capital-intensive sector. There is no more powerful lever for funding other development needs than to free up that money from the power sector and put it in things like money and health, or water and health and education, where it belongs. Also, the jobs resulting will be very widely distributed by occupation and location, and this will help reduce the urban-rural disparities and give everyone a chance at a decent life. I think the social and cultural capital questions are the most important. These are not any longer technical or economic problems. We have those solutions. We need to apply them with relentless patience. And in a spirit, I would suggest, of applied hope. You started by accusing me of optimism in a very gentle way. Optimism and pessimism are different sides of the same fallacy. They both treat the future as fate, not choice, and they don't take responsibility for creating the world we want. So I don't see the glass as half empty or half full. I see it as having 100% design margin expandable by efficiency. And I try to act in a spirit of applied hope. It's not the same as optimism, and it's not the same as theoretical hope. I can give you a little essay on this later if you like. But we've had for some years now pervasive fear, and now that things are tipping toward hope, let's make it applied hope and get on with it.
Thanks very much. Just one last question. We're actually running out of time. One last question. There was a questioner there.
Yeah, to follow the last excellent comment on social factors, I'd like to share one really beautiful line by a British architect who once said, technology is always the answer, but where were the problems? So I would say,
what was the question?
Yeah, particularly for China, I would say, it's really not a problem of technology. Of course, we can have we can develop smart technology really overnight. But let's say yes, you have a smart technology on building single-family house with low cost and energy efficiency, but given enormous population and scarce of land resource, so whether a single-family house is good at all, right? Whether in terms of public transportation, the car, automobile is needed at all, right? I would say that move to the urban planning issue, land settlement, that need the whole revolution of mindset on that. Yeah, I would say technology intersects with so many other problems.
Yeah, thank you. That's a beautiful example of where we need new thinking, or in a way reviving old thinking, because in an organically grown community, everything you want almost is within 5 minutes walk. I even lived in parts of London that were like that. and I never drove a car in 14 years in England. Now, I think we need to have very efficient cars, but also not to need to drive them much. My own country has been very bad in this respect because we mandated and subsidized sprawl. So you need a car to get anywhere. And the result is we design our communities around cars, not people. Now, if China goes in that direction, even if you have very efficient cars, instead of running out of air and oil and climate, you will run out of roads, land, patience, and ultimately rice. Not much arable land, and you can't afford to pave it. So I would suggest that having 1 billion Chinese driving cars makes no more sense than having 10 million Londoners or Los Angelenos driving cars. There isn't a place for all those cars. We need instead, I think, to have to be where we already want to be, so we don't need to go somewhere else. In other words, sensible land use. And then to have excellent virtual mobility, so we can just move the electrons and leave the heavy nuclei at home. And then have real competition at honest prices between all ways to get around or not to need to get around. This means walking, bicycling, public transport, a very wide range of technologies, including some new ones. But I think the future China should look more like Singapore and less like Bangkok. 1/6 of the GDP of Thailand disappears into Bangkok traffic jams because the infrastructure of cars is heavily subsidized. The cost of driving is socialized. Drivers get what they pay for, but they don't pay for what they get. Now, in Singapore, they do. Singapore charges the full social cost of driving. It has superb public transport and essentially no congestion. This, it seems to me, is a much more sensible way. And in a developing country context, more like a lot of China, actually, if you look at the 14th, the next to last chapter of our book, the Natural Capitalism book, you will find a case study of Curitiba, Brazil, which has the highest car ownership, except Brasilia, of any city in Brazil, and the lowest car drivership and the cleanest air, simply because they do not treat cars with favoritism. They treat cars neutrally, and they have to pay their own way. But the main objective is that everybody have fair access to safe, clean, fast, convenient mobility at very low cost. And they've achieved that beautifully by integration with land use, exactly as you say.
Well, thank you very much. My apologies that we've gone over time. I wish we can have you go on taking questions. And for all those with more questions and comments, you'll have to interact with Professor Lovins at the break. You may also read his books, of course. I do have one short question, but I know you won't have time to answer. I wonder what China is going to do with the surplus electricity. You mentioned that there would be a surplus electricity.
Turn off a lot of coal plants you won't need.
Can they pass it on to someone else? Well, thank you so much. And we have Stephanie, who will just direct us to do some little things. Stephanie, I don't think, Professor Lovins, I'm going to ask you to stay for a short time.
Okay, thank you, Professor Lovins, for the wonderful speech. May I now invite Professor Li Dan to join us on stage and to present a souvenir to Professor Lovins.
Professor Li Dan,
please.
Thank you so much. Thank you. Thank you very much. It's very kind of you. Thank you, Professor. Wow. Well, Stephanie, I'm going to change the time frame a little bit.
Okay.
Originally, we have 15 minutes for break. I need to shorten that to 8 minutes. If I can invite you to come back as quickly as possible. There are drinks outside for both students and our guests. We'd love to have students intermingle with our guests and feel free to talk to them and to have some drinks outside. So thank you very much again. And thank you, Professor Lovins, again. And can we ask you to come back within 8 minutes? Thank you very much. Thank you, Stephanie.